Hello and welcome back to my channel. I'm Varun Srivastav and this is video number 8. So today we are going to code linked list. Linked list is very fundamental data structure. Let's compare linked list with array to understand better. So array is a fixed length data structure. It's a linear data structure, obviously like linked list. But the main difference between an array and a linked list is that array is bounded. You define the number of element beforehand. So let's say you know that you're going to deal with only 10 items, then array is the best data structure to implement that functionality. But let's say you're not sure how many items you're going to work with, then linked list is the best option for you, because as soon as the item come, you can create that dynamically and append it to the list, and this list can grow on and on. But in case of array, that is not possible. And let's say you want to grow array, then you will have to create a bigger array, then copy your smaller array items to the bigger array, and then you can add more items to it. Array is bounded and a linked list is unbounded. So when I was in college, I found linked list a bit hard to begin with because I was missing the key point. And the key point is that you should know how it works at the memory level. What happens when you create a new object? How that object can be pointed to some or linked to some other object. And once you get the basis correct, like once you know how you can link another object to this one and how you can increment the chain, I mean, things become really easy. And once you have that basic understanding, linked list is like a piece of cake. Let's head back to the IDE and start implementing linked list. Quickly create a package structure, say linked list. And inside this package, I'll have a new class called myLinkedList. I'm giving a name myLinkedList because I don't want it to interfere with the existing Java linked list, because later on we are going to do some project in which we will compare both of these. So it's better that our name is different. And I'll create a new test class for this one because I don't do anything without creating a test first. myLinkedList. And I'll create an object of this inside before each setup step. myLinkedList. And in the teardown, I'll just destroy this object by giving it a null value. Then this is my first test case. So here I want linked list to add a new item to it. So it should append new item. Yep. So every time I create a new item, it will append it to the end of the list. So I want it to hold any object. So I'll just provide it a type. So for now, I just want to hold integer values. And this will ask me to change the signature of that class. But since we have the IDE, we'll ask IDE to do it for us. And yes, refactor. I don't need it here. Awesome. I'll say linked list.add 1. And I'll copy it 4 times. So this will be 5, 4, 3, 2, and 1. And then I want to assert on the size whether it is actually appending to this current linked list or not. So assert should be equal to 5 linked list.size. So I'm keeping the method same as you can find it in the original linked list. I'll import statically. I'll create this method, and this is going to be, let's make it t. This is going to be item t. All right. So now what we want to do is we want to take this item, create a new node in the memory, put this item as a value to that node, and save it, like add it to the list. So for that we need a starting node. So this will be a node class. If you remember, like this is the same node that we used in stack and queue. We are making use of the same node class. This will be the last node. So currently it will be null. So we'll check if our size is 0. Then I know that my linked list is empty. So my last node will become the new node. And here I will pass the value that I have. I have the item here, and the next will be null because currently it is not pointing to any other object. Let's say if we have some items in the linked list. Let's see, this is that example in the else block. Now our linked list is not empty anymore. So what we're going to do is we are going to create a temp variable where we will pass this last node pointer. So you can see temp is pointing to a memory location which was pointed by last node. So temp is now pointing to last node. Now I will make last node the new node that we are getting here with the value, and it won't point to anywhere. This is the new node, and new node is going to be appended at the end of the list, so it won't point to any other node. But which was the last node earlier, which is the temp now. Now this should point to our new node, which is the last node. Property, by default the size is 0. We have to increment the size and create this method so that it can return us the size of the linked list. And I'll just run this test case to see if it is working all fine. And then I can start with the second test case. It should remove item from the list. Now there are two things this can do. So we can either remove it by index or we can remove it by value. So in this implementation, we will remove it by index, and then we can create another overloaded method in which we will remove it by the item. We can copy this part in our setup step, because every time we want a new linked list that will hold 5 items, so we can remove all of this clutter from here. So our test case has become one liner. Now we want to remove an item from the linked list, so I'll remove it by index. So I'll say index 3. Let's remove index 3. So index 3 is actually the value 4. I will assert on the size first. Assert equals size should be 4. We can iterate over the linked list and see whether that index have been removed or not, or the item on that index have been removed or not. We can create that method. So after removing this, so here we are going to remove the item. So here we can ask the linked list to give us the first item in the link so that we can access the next node from the link, and that's how we can access and get to that fourth node. We will do it very manually here. We'll just ask for the first node. So linked list first node. So this should give us the first node, and the value should be of type node. Dot value. Five, because we have removed the third index, and third index will contain the value 4. So our fourth index will now contain value 5. Simple. And if you don't understand any of this, do comment below. I'll get back to it as soon as I can. Great. So moving on, we will return the first node, and we don't have that yet. We'll create a reference to the first node. This will be same as last node, but this won't change. So our last node will become the first node. And this is how we can return the first node. And we are not going to change first node after that. It will always be changed when the size is 0, and that's all. First thing that we want to do is to decrement the size. Then we have to remove the item, and this is the index. And this will always be an integer. So let's say index is 3. So I'll iterate till 2, and then I will remove the next item. I'll iterate over it. So in every iteration, my temp node will fetch me the next value. So once the iteration is over, I know that I have to remove the next item from the list. I'll get next, and then I'll get next. what I'm doing is I am pointing node number 3 to node number 5 directly. I'm skipping the fourth node here, breaking the link to fourth node, and the garbage collection will automatically remove that node and free up that memory. Let's see. Null pointer. Very well. Temp is null. Oh, it was I++. My bad. Definitely it won't work because the condition was all messed up. Very silly mistake. Okay, this is good. This is expected. So we expected 5, but it gave us 4. It means that somewhere here we have made the mistake. So let's iterate over and see what happens. So first time 0, I'm getting the second one. Okay, I have to run it till here. And then it will remove the fourth one. Correct. Okay, so this is how you do it. And I'll take a pause. I'm getting a call. Let's run all our test cases again and see if it is working fine and we have not broken any other functionality. Very well, we're good here. Now we'll implement the get functionality, so get by index. So I'll create a test case for that. It should get the value by index. So what I'm going to do is I'm going to keep the same, like I'm going to fetch the third index, which will give me the value 4. linklist.get, and I will pass the index here, and it should give me a node of value 4. Let's call it result, and assert equals, it should be 4 result. Create method, and the return value will be the item type. So our loop is going to look pretty much the same, except the size thing here. So we have the first node. We'll start with first node and we'll reach to that particular node and we'll just return it. So this is the one that we want to return. temp.getValue. So now this should work. Whoa, failed. So expected is 4 and it is actually giving us 3. Okay, this is not going to be -1. This is going to be till that index. So today I'm feeling very sleepy, so excuse me if I make such mistakes. So program's right. Cool. So now we are going to implement another functionality. So it should remove item by value. So far we were passing index. Now we'll pass the object itself, like whatever the value we want to remove. So our item is going to be 2. So I want to remove the node that contains the value 2, or that contains the item 2. linklist.remove, I'll pass in the item. Currently it will take it as integer, but I want it to be wrapped around integer. And this is going to remove that item from the list. And how can we assert this? We can assert it in the same manner we did in the previous test case. This method will be overloaded. So in this case, we are going to take remove by item. Everything's going to be same, pretty much the same. And this is not going to be index. Let's make this for loop a while loop. So while temp dot next is not equal to null, assign temp to the next one. And we'll check here if temp dot get value dot equals the item, then we have to remove it. So the remove functionality is going to be pretty much the same. And here, like, we are going to take this code. We don't have to reach till this point. We have to see if next dot get value equals item. Then we can proceed as usual. And once this is done, we will decrement the size by 1. Okay, in this case, what's happening is it is running the same code and trying to remove it by index, but this is not what we want. So I think overloading is not working in this case, so we will have to change the method name. So I'm going to change this to remove index. It's more clear now. Select all, refactor. So this one will become remove index. Okay, but where's the one? Okay, everything is remove index. Now we want this to be remove. And here I'm going to go here and change this one to remove. So this will be removed by value, that will be removed by index. So let's run this one and see if it works. Indeed, that was the problem. And run all the test cases again just to make sure. Great. Now we have removed by index, we have removed by item, we have a append functionality, we have a remove functionality, we have the first node with us. What else? What else linked list can do for us? I mean, for now, let's keep it this way. And whenever we need a new functionality, we'll come back and implement that. So here we have implemented a working linked list. In the next video, we are going to implement doubly linked list. And doubly linked list is pretty much the same as singly linked list, but it points both ways. So you can go forward as well as backward. Let's implement that in the next video. See you there. Bye-bye.